In this video, we're going to finish your Unit 2B review, starting with this group of problems, numbers 13 through 16. What I'm going to help you with on these problems is this part of the directions: define variables for the unknown quantities and write a system of equations. And then I'm going to leave it up to you to solve those systems. And you can use any method you want: graphing, substitution, elimination, or matrices. I think you'll find that matrices will probably be the most convenient. Then I'll also tell you what the right answers are. So if you have any questions about the solving of these systems using one of these methods, probably matrices, be sure and ask me in class. All right, so let's take a look at number 13. It says Andy's mail order business ships packages in 2 different weight classifications. On Monday, he mailed 10 packages at a lower weight classification and 6 boxes at a higher weight classification, weighing a total of 412 ounces. On Tuesday, he shipped 8 packages at a lower weight classification and 14 packages at a higher weight classification, weighing a total of 716 ounces. Now, take a look at the question. How many ounces is each weight classification? All right, so we have 2 classifications. There's a lower one and there's a higher one, okay? So when you go to define your variables and tell or describe what quantities they represent, always look at this question, okay? It'll guide you on what to do. How many ounces is each weight classification? Well, there's 2 weight classifications, so we're going to need 2 variables. Let's just use x and y. Let's let x be the number of ounces in the lower weight classification. So number of ounces in the lower classification. And then let's let y represent the number of ounces in the higher weight classification. Okay, so now, since I have 2 unknowns, to solve for these 2 unknowns, I'm going to have to write a system of 2 linear equations. So to do that, let's go back and look at the problem. I'm going to change colors. Let me change to yellow. All right, and let's take a look here where it says what happened on Monday. On Monday, he mailed 10 packages at the lower weight classification and 6 packages at the higher weight classification for a total of 412 ounces. So that's going to represent one of our 2 equations. So we have 10 packages at the lower weight classification. So if I have 10 packages, each package weighing x ounces, then 10x would be the total weight of those packages at the lower weight classification. Plus, I'm going to add to that the 6 packages that weigh y ounces each. So 6 times y would be the total weight for those packages mailed at the higher classification, and then that totals 412 ounces. So there's one of our 2 equations. Now to get the second equation, let's go back and look at the problem, see what it says. Let's see what happened on Tuesday. On Tuesday, he shipped 8 packages at the lower weight classification and 14 packages at the higher weight classification for a total of 716 ounces. So that sentence will provide our second equation. So 8 packages at the lower weight classification would be 8x for the total weight there, plus 14 packages at the higher weight classification, that would be 14 times y, okay, and then the total weight for both of those groups of packages would be 716 ounces. All right, so looking at these numbers, or looking at these equations, I think the most convenient choice for getting your solution quickly would be to use matrices. I will leave that up to you. And when you're done, you should get the following answers. Your lower weight is, let's see, 16 ounces. Okay, and the higher weight classification, or the number of ounces in the higher weight classification, is 42 ounces. All right, so those are your answers. So you work out the problem using whatever method you want, and these are the 2 answers you should get for x and y. All right, then let's move on to number 14. 14 says the concession stand at a football game sells large drinks for $6 and small drinks for $4. There were 491 drinks sold during the game, bringing a total revenue of $2,700. Okay, so the question is, how many large drinks and how many small drinks were sold? All right, so when we go to define or go to identify or define your variables and what they're going to stand for, go to the question. What is it asking you for? How many large drinks and how many small drinks were sold? So why don't we let our large drinks be X, okay, the number of large drinks, and the number of small drinks be Y, okay? So X is going to be number of large drinks, and Y is going to be the number of, sorry about this bad handwriting, Y is going to be the number of small drinks. All right, and then let's go back and take a look at the equation. Again, it's really hard to write on this air slate, so I apologize for my bad handwriting. Okay, let's go back and look at the equation, see if we can come up with two equations. Since we have two unknowns, we need two equations. All right, so small drinks are $6 each. Good grief. Small drinks are $4 each. So our first equation is going to have to do with money. If we sold X large drinks at $6 each, then 6X would be how much money was brought in when you sell those large drinks. Then we're going to add to that the amount of money brought in selling small drinks. Well, we sold Y of those at $4 each. So 4 times Y is how much money came in for those. And then the total amount of money that was brought in was this $2,700. $2,700. All right, so there's one of our equations. The other equation is going to have to do with the total number of drinks. Okay, X is the number of large drinks, Y is the number of small drinks, and together they sold a total of 491 drinks. And so our second equation will be X plus Y is equal to 491. All right, at this point, use any method you want. Probably matrices is what you'll choose to get your solution. And when you do, you should end up with 123. X is 123. That's how many small drinks were sold. And then the number of large drinks sold was 368. All right, so again, if you're having trouble getting these two solutions, be sure and ask me in class. All right, let's move on then to number 15. Okay, number 15 and 16, these are both going to represent 3 unknowns, so you're definitely going to want to use matrices to solve these two equations. Number 15 says, Donnie, Dan, and Matt stopped at Cheesy Cheeseburgers after class. Donnie bought, let's just underline this, Donnie bought 2 cheeseburgers and 1 large drink and 2 orders of fries and spent a total of $4.81. Dan, let's talk about Dan. Okay, Dan bought 3 cheeseburgers and 2 large drinks for $5.57. Notice, no, he didn't buy any fries. And then Matt, let me change color again here and underline this next part in a different color. All right, Matt bought 1 cheeseburger, 1 large drink, and 1 order of fries for $2.83. Okay, now look at the question. The question says, what is the price of each cheeseburger? What is the price of each large drink? And what is the price of 1 order of fries? So let's choose 3 variables. How about X, Y, and Z to represent for each of those? So we're going to let X be the price of 1 cheeseburger, Y be the price of 1 large drink, and Z be the price of 1 large fry. So X is price per cheeseburger. Okay, Y is going to be the price per or for each large drink, and then Z will be the price for 1 order of fries. price for 1 order of fries. Okay, so now look at the 3 sentences that I've underlined in 3 different colors. That's how we're going to get our equation. Okay, so let's start with Donnie. 2 cheeseburgers, okay, at X dollars each would be 2X, plus 1 large drink at Y dollars each would be plus Y, and then add that to what he spent on fries. He ordered 2 orders of fries. Each fry costs Z dollars, so that would be 2Z. And then he spent a total of $4.81. Okay, the second guy, Dan, he bought 3 cheeseburgers, so that would be 3X, okay, and then 2 large drinks, okay, so that would be plus 2 times Y. And then notice he didn't buy any French fries, okay? But when you think ahead at that 3 by 3 matrix that will represent your coefficient matrix, we need to have a coefficient here. So let's go ahead and add a term with a 0 coefficient. That way we'll have a coefficient to put in that second row, third column when you make your coefficient matrix. And then Dan spent a total of $5.57. All right, let's take a look at the third equation that's underlined in green. Matt bought 1 cheeseburger, so that would be X times 1, plus he bought 1 large drink, and he also bought 1 order of fries, and he spent a total of $2.83. All right, so then go ahead and set up your coefficient matrix, your constant matrix. Take the inverse of the coefficient matrix times the constant matrix to get your solution. And when you do, you should get, let's see, $1.29 for the price of a cheeseburger. Okay, 85 cents for the price of 1 drink. And then French fries are 69 cents each. All right, so those are the 3 solutions you should come up with. Okay. And then number 16, let's do one more 3 by 3. And by the way, on the test on Thursday, you won't be solving this many systems. Some of the questions will be just set up and don't solve. Okay, so you will need to know how to set up every one of these equations, but I won't have you solve this many on the test or we'll be running out of time. All right, number 16. In triangle, what does that mean? That means 3 angles, right? In triangle ABC, the measure of angle B is 2 more than 3 times the measure of angle A, and the measure of angle C is 8 more than the measure of angle A. The question says find the measure of each angle. I have no idea why this E is here. Let's just mark that out. That's a typo. All right, so now we have a triangle has 3 angles, right? Hence the name triangle. And we're asked to find the measure of each angle. So since there are 3 angles, that means 3 unknowns. How about instead of A, B, and C this time, let's use little a to represent the measure of angle A. Let's use little b to represent the measure of angle B, and let's let little c represent the measure of angle C. All right, so 3 unknowns, that means I have to come up with 3 equations. Well, the first is kind of implicit. It's not really mentioned directly in this problem, but you need to go with what you know about triangles. And the measures of the 3 angles of a triangle, you should remember from geometry that they total 180 degrees. So our first equation is just going to be A plus B plus C, measure of angle A, plus the measure of angle B, plus the measure of angle C would total 180 degrees. All right, now our second equation is going to come from this sentence, that the measure of angle B is 2 more than 3 times the measure of angle A. So we're going to take those words and translate them into algebra. The measure of angle B is represented by this little b. Okay, then it says is, okay, that word is going to be translated into an equal sign. So the measure of angle B is 2 more than, well, that would be 2 plus 2 more than what? 3 times the measure of angle A. The measure of angle A is little a. We're going to take 3 times that, so it'd be 3a. And then the third equation will come from the next sentence that says the measure of angle C is 8 more than the measure of angle A. So the measure of angle C is represented by little c, and that is or is equal to 8 more than, so I'm going to say 8 plus the measure of angle A. Little a is used to represent the measure of angle A. All right, now, if we're going to use matrices to solve this system of equation, we need to first of all get them all three into standard form. Okay, so I'm going to rewrite these. The first equation is fine. I have an A term, a B term, a C term in that order on the left, a constant on the right. So just rewrite the first equation as is. Okay, the second equation, though, I need to move some terms around. I want my A term first, so I'm going to take this 3A and move it clear over here to the left side, and I'll do that by subtracting a 3A from both sides. So when I move this 3A to the left, it's going to become negative 3A. Okay, we already have a positive B term on the left, so I'm going to say plus B. And then there's no C term, but I need a coefficient for the C term, so let's just add a 0 times C term to get that C term represented, and then this positive 2, which was already on the right side of the equation, goes right here. All right, then the third equation to get it in standard form. Again, I'm going to take this A and move it to the left side of the equal sign by subtracting it from both sides, so it will become a negative A on the left. Notice there's no B term, but I need a B coefficient, so let's add a 0 times B term. And then finally, the positive C is already on the left, so we'd write plus C, and that's all equal to this positive 8 that was already on the right side. All right, so there's your system of equations with each equation written in standard form. Now set up a coefficient matrix, a constant matrix, take the inverse of the coefficient matrix times the constant matrix to get your solution. And when you do, you should get that the measure of angle A is 34 degrees. The measure of angle B is 104 degrees. The measure of angle C is 42 degrees. All right, so let's move on now and talk about linear inequalities. Okay, so this is one thing you'll be asked to do on your test. Given a system of linear inequalities, okay, you're going to determine if any of these points are in the solution set, right, yes or no. Okay, so let's start with the point 0, 0, which is right here. Okay, well, the solution set would be this area, the area that's shaded in both from both linear inequalities. Since 0, 0 isn't in that area, we're going to say no to that. Okay, let's take a look at the point 1, 1 that lands right on this solid border. Since it's on the solid border, it's in the solution set, so we will say yes to that one. 4, 0, 1, 2, 3, 4 lands on a dotted border. Okay, so these points on the dotted border are not included in the solution set, so say no to that one. Okay, and then the point 1, negative 6, I'm going to go to the right one and down 1, 2, 3, 4, 5, 6. Okay, this clearly is not in the solution set. Okay, it's in neither of the single linear inequalities. And then finally 3, 2, if I go to the right 3 and up 2, that lands in our shaded solution set area, so we would say yes to that one. All right, moving on to number 18. Okay, is the point negative 3, 4 a solution to the following system of inequalities? Well, you've done this same process with systems of linear equations. Put negative 3 in for x, put 4 in for y in both equations. If it makes a true statement both times, that means it would be a point that would land in one of these regions that's double shaded. Okay, so let's start with the first equation. 5x minus y is greater than or equal to negative 10. So I'm going to go back and replace 5 with negative 3. So that would be 5 times negative 3 minus, I'm going to replace y with 4. Okay, and let's see if that is greater than or equal to negative 10. Let's do the arithmetic. Well, 5 times 3 is negative 15. And negative 15 minus 4 is negative 19. Okay, is negative 19 greater than or equal to negative 10? You might want to think about temperature. Isn't negative 19 a colder temperature than negative 10? Okay, it is not. I mean, it is a colder temperature, so it's a lower temperature. If you think of a number line, negative 19 does not lie to the right of negative 10, it lies to the left of negative 10. So when I put my ordered pair in the first inequality, it did not work. So I don't even need to check the second one. I'm going to real quick just do it for the fun of it. Negative 3 plus 4, is that greater than 0? Yes, it is. Negative 3 plus 4 is 1. 1 is greater than 0. So this ordered pair works for the second inequality, but since it didn't work for the first one, we say no, it is not a solution to the system of linear inequalities. Okay, and then last but not least, number 19, we're going to graph this system of inequalities on this line. I'm just going to warn you ahead of time, it's hard to do this on the air slate. When you do it on paper with a straight edge, you'll get a better graph than probably what I'm going to get. All right, let's start with the first inequality, and let's go ahead and put it in, solve it for y, okay? I'm going to subtract 3x from both sides. When I do, I would get y is less than, now I subtracted 3x to move it to the right, so it would be negative 3x on the right, and then plus 4. Okay, so the boundary for this linear inequality would have a y-intercept of positive 4, and then a slope of negative 3, or negative 3 over 1. So I'm going to go down 1, 2, 3 to the right 1, down 1, 2, 3 to the right 1, and then since I have a strictly less than symbol, I'm going to draw a dotted line, attempt to draw a dotted line through these points. And hopefully it'll be, oh, it's not doing very well. Okay, when you do this on your paper, it'll hopefully look a lot better than mine. Okay, so there, pretend like that's straight. And since this is less than, that means we're going to shade below. So shade the area below that line. All right. Now our second inequality is already solved for y, so I don't need to do what I did on the first one. It has a y, you know, I'm going to change color. Let's change to green. All right, it has a y-intercept of positive 1 and a slope of negative 1/2. Now this negative 1/2, I can think of it as negative 1 over positive 2, or I could think of it as positive 1 over negative 2. Either way, I should end up with points on the same line. If I use this for my slope, I would go down 1 and to the right 2, down 1 to the right 2, down 1 to the right 2. Okay. And then I'm going to draw a solid line, attempt to draw a solid line through those points. Okay, it's really hard on this air slide. I'm so sorry about these straight lines. Use a straight edge on your sheet and it'll look a lot better. Okay, and since this is, a less than, I'm going to shade below that solid green line. Okay, so one inequality to go. Let's go ahead and graph this last one. Now, y greater than negative 3. The boundary is going to be a horizontal line. Remember HOY? Okay, horizontal lines have a slope of 0 and their equations are y equals a constant. So I'm going to draw a horizontal line through negative 3 on my y-axis, but it's going to be a dotted line because of this strictly greater than. So I'm going to switch colors again to, how about purple? Okay. And I'm going to draw a horizontal line through negative 3. 1, 2, 3. So it's going to go right there. It's dotted because of the strictly greater than symbol. And we're going to shade everything above the line because all the points above the line would be those points where the y value is bigger than negative 3. So shade in. All right. And now, created kind of a mess here. But what I'm going to do is go back and change to yellow, and I'm going to shade in all the points that are red and green and purple all at the same time. So let me switch to a yellow color. That would be all these points in this region, okay? Not including the point on the dotted line. Okay. There we go. So everything that I have shaded yellow. And this solution set would not be bounded on the left side, so this continues, okay? It just continues on and on, getting wider and wider. So what I've shaded in yellow then here is our solution set to the system of inequalities to the left. All right, so if you have any more questions, be sure and ask me in class. And guys, you might want to cover up these answers and try them again on your own, because when you take the test, you need to be able to work these problems. Working them on your own is a much different skill than watching somebody else do them. So it wouldn't be a bad idea to practice these problems again. Good luck, and let me know if you have any further questions.